Welcome to our introduction to path vector routing, an essential protocol that facilitates communication across the internet. In this video, we will explore path vector routing, a method that enables the sharing of routing information between different networks, known as autonomous systems. Unlike traditional routing techniques, path vector routing tracks the complete path that data packets take to reach their destinations. Path vector routing protocol used to manage the exchanging of routing information between different autonomous systems, primarily in inter-domain environments such as the global internet. It is an extension of the distance vector routing protocol designed to operate at a large scale, ensuring better control and stability across distinct administrative boundaries. The most well-known implementation of path vector routing is the Border Gateway Protocol. Simply, it is called BGP, which is the standard for routing between autonomous system and the internet. PGP uses the autonomous system path attribute, which records the sequence of autonomous systems that a route has traversed, helping routers make decisions based on the policy, preference, and loop prevention. Here are the key characteristics of path vector routing. Each route carries the full path of autonomous system that the data must traverse to reach the destination. This helps in preventing routes loops, a major issue in larger networks. By including the autonomous path information in the routing updates, it avoids routing loops by allowing routers to detect if their autonomous system is already in the path. Path vector routing allows policy-based decision based on the autonomous system path. Routers can prepare or reject routes based on the autonomous systems involved, making it flexible for administrators to control traffic flow between domains. In terms of scalability, it is designed to scale well across large and complex networks like the internet, where distance vector and link state protocols may not perform efficiently. Convergence time is slower compared to the other algorithms like link state routing, but it is manageable at an inter-domain level due to the relatively static nature of autonomous system connection. Path vector routing operates at the level of autonomous system, making it suitable for use between different organizations and domains that control their own internal routing is independently. Instead of broadcasting the entire routing tables, routers using path vector routing send only the changes, making it more bandwidth efficient in large networks. Here is an overview of the pros and cons of the path vector routing. By tracking the full path, it avoids routing loops, making sure data does not get stuck in a cycle. It works well for large networks like the entire internet. Network operators can choose routes based on the business needs or policies, not just shortest paths. It reduces the routing table size by summarizing the multiple networks into a single route. It helps manage IP address more efficiently because it supports classless interdomain routing. Similarly, the cons of the path vector routings are slow updates. It takes time to adjust when network changes happen, which is an slow down routing. Configuring it is complicated, requiring careful planning and management. It needs more processing power to handle detailed path information. In the aspect of security, It is vulnerable to attacks like route hijacking. Suppose if it is not properly secured. Different network policies can lead to inefficient routing in the case of path vector routing. Path vector routing has several key applications across different types of network. Here is how it is used. Path vector routing forms the backbone of the global internet routing via border gateway protocol. It manages how data travels between different autonomous systems and the internet. It is primarily used in interdomain routing, which means routing between different networks or organizations. BGP ensures that data can move between various autonomous systems that make up the internet. Telecom providers and internet service providers use path vector routing to manage traffic between their networks and others. It helps optimize the routes data takes across vast distance and multiple network providers. In the telecom sector, path vector routing ensures efficient communication between large network areas and different service regions. In cloud computing and large data centers, path vector routing helps manage traffic across multiple data centers or cloud regions, ensuring optimal data delivery across the different autonomous systems. Large enterprises uses path vector routing for managing traffic between their various offices or data centers, especially when spanning multiple countries or regions. In this section, let us see the working of path vector routing with an example. The principle of path vector routing is similar to that of distance vector routing. In path vector, we assume that there is one node in each autonomous system that acts on behalf of the entire autonomous system. This is called a speaker node. The speaker node in an autonomous system creates a routing table and advertises it to speaker nodes in the neighboring autonomous system. The speaker node advertises the path, not the metric of the nodes in its autonomous system or other autonomous system. The idea is the same as for the distance vector routing, except that only speaker nodes in each autonomous system can communicate with each other. There are three important processes in the path vector routing: initialization, sharing, updating. The first one is initialization. Each speaker node can know only the reachability of the nodes inside its autonomous system. Node A1 is the speaker node of the autonomous system AS1, B1 for AS2, C1 for AS3, and D1 for AS4. Node A1 creates an initial table that shows A1 to A5 are located in AS1 and can be reached through it. Node B1 advertises that B1 to B4 are located in AS2 and can be reached through B1 and so on. The second level is sharing. A speaker node in an autonomous system share its table with immediate neighbors. Node A1 share its table with B1, C1. Node C1 share its table with B1 and D1. Nodes B1 share its table with A1 and C1. Node D1 share its table with C1. When a speaker node receives a two-column table from a neighbor, it updates its own table by adding the nodes that are not in its routing table and adding its own autonomous system and the autonomous system that send the table. After a while, each speaker has a table and knows how to reach node in other autonomous system. In summary, path vector routing provides robust and controlled scalability, making it ideal for large networks like the internet. However, it suffers from complexity, slower convergence time, and security concerns that must be addressed by the network operators. Thank you for watching.